All right, so we have on here that we're finding trig functions again with reference angles. So if we have an angle theta, and it's a non-quadrantal angle, meaning it's not on one of your axes, in standard position, its reference angle, which we notate this way, it looks like theta and then an apostrophe, but it's read as theta prime, is the acute angle formed by the terminal side of theta and the x-axis. So this is important as to where the reference angle is. It's the acute angle between the terminal side and the x-axis, not the y-axis. And the rules for finding measures of reference angles for theta between 0 and 360 degrees or between 0 and 2 pi if you're in radians are shown below. Now, I'm going to stress this again. This isn't necessarily something, these formulas below, that you would need to memorize, but it is there to help you as we get started with reference angles. So if your terminal side of your angle theta is in quadrant 1, then your reference angle theta prime is just equal to theta. So the angle theta would be the same as the reference angle. If your terminal side is in quadrant 2, so you can see where theta is, your reference angle is between that terminal side and the x-axis, so this is the angle that would be theta prime. So if you were finding the measure of that angle, this is how you could find it in degrees and in radians. You could take 180 degrees, since 180 degrees would be this angle here, and then subtract your angle theta. That would give you that angle. Or if you're in radians, 180 degrees is equal to pi radians, so you could take pi and subtract your angle theta to get that radian measure. If the terminal side is in quadrant 3, so you can see the angle theta that's created, theta prime, the reference angle, again, is between that terminal side and the x-axis, which again, that would be 180 degrees or pi. So here's how you could find that measure. Now, because that the angle theta would be greater than 180 degrees or greater than pi radians, you would take your angle theta and subtract 180 or subtract pi to find the reference angle. And then if your terminal side is in quadrant 4, your reference angle is between that terminal side and the positive x-axis, and that would be 1 revolution, so that would be 360 degrees or 2 pi if you're in radians. So to find that reference angle, you could take 360 minus theta or 2 pi minus theta to find the reference angle. Your reference angle should always be an acute angle. So the reference angle should always be between 0 and 90 degrees or between 0 and pi over 2. And the reference angle is also always positive. So it does say here if your measure of theta is greater than 360, so if the original angle makes more than 1 full revolution, then you're going to use a coterminal angle with a positive measure between 0 and 360 or between 0 and 2 pi to find the reference angle. So we'll go through some examples here. And again, your unit circle can be helpful in terms of knowing where about to draw these as well. Not all of your angles for these problems will be labeled on your unit circle, but you can get an idea of where those angle measures should be. So for example 1, we're sketching the angle and then finding the reference angle. So we're going to sketch the angle 330 degrees in standard form, and that is on your unit circle. So the terminal side would be about here. And I'm just going to draw from 0 degrees around to show that theta is 330 degrees. So then the reference angle is between the terminal side and the x-axis. And if it helps, you can look at that box above as to where the reference angle will be if the terminal side is in quadrant 4. This angle here is the reference angle theta prime. and then we have to find that measure. So for reference angle, I'm going to put theta prime equals, just to get you used to that notation of seeing theta prime and what it means. So when the terminal side is in quadrant 4, to find this measure, we can take 360 degrees and subtract the original angle of 330 to see that the reference angle theta prime is equal to 30 degrees. Questions on example 1? All right, and then example 2, this one is in radians, and it is a negative angle. So theta is negative 5 pi over 6. So think of, again, how we broke that unit circle down into fractions. If you're starting at 0 and it is negative, so we're going clockwise, if we went halfway around, that would be equal to 1 pi, which in 6 is 6 pi over 6, meaning 5 pi over 6 would be about here. So not quite halfway around. Again, you're going clockwise because it's negative. So this is theta, meaning the terminal side is in quadrant 3. And that means this acute angle here between the terminal side and the negative x-axis is theta prime. And now, well, anybody have a guess as to what theta prime is? What angle? Okay, I heard you say, whisper something. 30 degrees in radians, it would be? Yes. So theta prime is going to be pi over 6. And if you are given an angle in radian measure, you should give the reference angle in radians as well. A couple ways to find this. I know that this is in quadrant 3, and by the rules up here, you should be taking the original angle theta and subtracting pi in this case. But because the angle measure is negative, if you take negative 5 pi over 6 and subtract 6 pi over 6, you're not going to get pi over 6. So you could think of this as being 6 pi over 6 minus 5 pi over 6 because it's a negative angle. That to me would be the best way to think about it. Or you could see on the unit circle that you filled out that where negative 5 pi over 6 is, it's equivalent to 7 pi over 6. So you could take 7 pi over 6 and subtract 6 pi over 6. So however you reason through it, or if you reason through it in degrees and then convert it back to radians, that's fine as well. But are there questions on number 2? Okay, so I just have a couple more. Number 3, we have a negative degree measure. So we have negative 110 degrees. So again, we're starting at 0 degrees and we're going clockwise. We know halfway around is 180. So we don't want to quite go halfway. A quarter of the way is 90 degrees. We actually want to go a little bit past there. So about here, because 110, well, it's negative 2, but that's on your unit circle. So this would be theta. So again, terminal side is in the 3rd quadrant. Theta prime would be between that terminal side and the x-axis. And we need to find that measure. Ideas on what that measure is? 70 degrees, yeah. So again, if we use what we had done above, because this angle measure is negative, you could find that by taking 180 degrees and subtracting 110, again, because it's negative. And that would give you the 70 degrees. And the last one, number 4, 2 pi thirds. This angle is on your unit circle. You can see about where that is. So here in quadrant 2, it's a positive angle, so we're going around counterclockwise. And then our reference angle between that terminal side and that negative x-axis. And we'll find the measure of theta prime, which would be pi over 3, yes. So here we could take, the rule for quadrant 2 would work with our positive angle. If halfway around is pi in thirds, that would be 3 pi thirds. And so if you subtract 3 pi thirds minus 2 pi thirds, that would give you 1 pi thirds, or just pi thirds. All right, any questions right now on just finding reference angles, Maria? 3 pi thirds. This is 3 pi thirds, not 2 pi thirds. Oh. Sorry. It is a 3, not a 2. So 3 pi thirds would be equivalent to pi, so I'm taking pi minus 2 pi thirds. Other questions? Okay. We are still going to be finding reference angles for the next examples, but we're going to be doing more with those. So we have looked at finding values of trig functions using reference angles, even though we didn't talk about them as reference angles before. But as it says on top, you can use reference angles to evaluate trig functions for any angle theta. The sign of a function is determined by the quadrant in which the terminal side of theta lies. So I'm going to explain this here in a minute. So to find or evaluate trig functions for any angle theta, you want to first find the measure of the reference angle, theta prime, what we just did. Evaluate the trig function that it's asked for theta prime. And then you're going to determine the sign of the trig function value, meaning is it positive or is it negative? And you're going to use the quadrant in which the terminal side of theta lies to determine that. So what this shows you, it shows you, notice each trig function, sine, cosine, tangent, are paired with their reciprocals. So sine is paired with cosecant, cosine with secant, tangent with cotangent. And it shows you which trig functions are positive in which quadrants. So in quadrant 1, all trig functions have positive values. In quadrant 2, only sine of theta, and therefore its reciprocal cosecant of theta, are positive. Cosine and its reciprocal and tangent and its reciprocal are both negative. So only sine is positive in quadrant 2. In quadrant 3, only tangent and its reciprocal are positive. So sine, cosine, and the reciprocals are both negative. And then in quadrant 4, only cosine and its reciprocal are positive. Sine and tangent and the reciprocals are both negative. So a way to remember this, which quadrant, which trig functions are positive, and if you go on to take trig pre-calc next year, you'll hear Mrs. Fulba say this as well. I'm going to put A here for all, S for sine, T for tangent, C for cosine. And she has a saying that says all students, or a mnemonic device, if you will, all students take calculus. So if you can remember that, all students, meaning all trig functions, are positive in quadrant 1. For students, S goes with sine. Sine is positive in quadrant 2. Take T for tangent. is only positive in quadrant 3. And then C for cosine, cosine's positive in quadrant 4. So all students take calculus. Just a way to remember what trig functions are positive where. So we're also going to be using the relationships of the special right triangles to determine the exact values of trig functions. So in these examples 5 and 6 and on your assignment, make sure you are finding the exact values, not a decimal approximation, but the exact values. And in these special right triangles, you will be using the value 1 for x. So for example, when you see in the 30, 60, 90, that the one side is just x, you're using that side then equaling to 1 when you find your trig values. X times the square root of 3 would just be 1 square root 3, so square root 3. 2 times x is 2 times 1, so that would just be 2. And then for the 45, 45, 90, the two legs would just both be 1. The hypotenuse would just be 1 square root 2, or just square root 2. So for 5 and 6, finding the exact values of each trig function. So for 5, we want the exact value of cosine of 135 degrees. So you are not just typing it in your calculator. That may not give you the exact value. Following the 3 steps above, we first need to find the measure of the reference angle theta prime. So here theta is 135 degrees. We want to find what that reference angle would be. So I'm just going to sketch, like we had done just for the first 4 examples, I want to sketch where this angle would fall. Now, these angles that you're going to be working with in this part will be on your unit circle. So if you find where 135 degrees is, it is in quadrant 2. So this is theta. Meaning then our reference angle is between that terminal side and the negative x-axis, so that would be theta prime here. And what would the value of theta prime be? 45 degrees. All right, and I will say your reference angles for this part as well should be either 30, 45, or 60 degrees, or their corresponding radian measures as well. So they should be one of the angles, not 90, one of the angles you see in the special right triangles, 30, 45, or 90. If you're getting something different for this type of example, let me know. Something might not be calculated correctly. So what this means is that cosine of 135 degrees is equal to, I'm going to leave a little bit of space here because we're going to have to determine if it's positive or negative, but it's equal to cosine of 45 degrees. So the reference angles means that the cosine or a trig function at that angle is the same as its reference angle, give or take a negative sign. So here's where step 3 comes in and where this diagram comes in. Because this terminal side is in quadrant 2, cosine is negative in quadrant 2. So I need to have a negative sign there. The answer itself should be negative, is what that means. So if you want to make a note, this is negative because that terminal side is in quadrant 2. Cosine is negative in quadrant 2. But now we're going to use these special right triangles to find what cosine of 45 degrees is. So we know we're going to have the negative sign here. What is the ratio in terms of opposite adjacent hypotenuse for cosine? Cosine is adjacent over hypotenuse. So you have two 45-degree angles. Let's just say I use this one. The adjacent side is 1. The hypotenuse is the square root of 2. So cosine of 45 degrees would be 1 over the square root of 2. and it is negative again because of quadrant 2. We cannot leave a square root in the denominator. It's not simplified. How do we get rid of that? Multiply by root 2 over root 2. So this would be negative 1 square root 2 on top, so square root of 2, over square root of 2 times the square root of 2 on the bottom is just 2. So this is the exact value of cosine of 135 degrees. If you typed in cosine of 135 in your calculator, you would get a decimal approximation, so you would not get the value in this form. Questions on example 5? All right, example 6, very similar, but here we have cotangent, so we have a reciprocal function. That's okay. We also have a radian measure, not a degree measure. So your answer, your answer is not going to be in degrees or radians. So it might be easier for you, and I'll show this as well if somewhere in the problem you do convert to degrees. But I'm just going to sketch this angle theta, 7 pi thirds. And that is also on, well, actually it's not on your unit circle, because going all the way around once is 2 pi, which is 6 pi thirds. So you'd have to go another pi thirds. Yep, so 7 pi thirds would be here, but it's more than 1 full revolution. Meaning then our reference angle theta prime is here between the terminal side and the x-axis. And what would the value of theta prime be? In degrees, it would be 60. So way to think of this, because we went all the way around once, we had to go an additional pi thirds to draw this angle. So theta prime is pi thirds. It is okay, though, if you switch that to degrees, and you can use your unit circle to do that. If you look at your unit circle, pi thirds is at 60 degrees. So the reference angle is 60. You are going to actually want degrees when you're using the triangles to find the exact values. So here we have that cotangent of 7 pi thirds is going to equal, again, I'm going to leave a space, we'll figure it out if it's positive or negative, but it'll equal cotangent of 60 degrees. We're in quadrant 1 for the terminal side, so will it stay positive or become negative? Stay positive, everything is positive in quadrant 1. And then to find cotangent of 60 degrees, cotangent is a reciprocal function. What is it the reciprocal of? Sine, cosine, or tangent? Tangent. Tangent of an angle is what ratio in terms of opposite, adjacent, hypotenuse? What ratio is tangent? Opposite over adjacent, TOA. Meaning then cotangent is adjacent over opposite. It's the reciprocal. So on the 30, 60, 90 triangle, find the 60 degrees. We want adjacent over opposite. The adjacent side is 1. Over the opposite side is the square root of 3. So it's 1 over the square root of 3. And it stays positive because the terminal side's in quadrant 1. Just like for the previous example, we cannot leave a square root in the denominator, so we would multiply by square root of 3 over square root of 3, meaning this is square root of 3 over 3. And that would be the exact value.